Unit 2, Murphy's Law.
Good afternoon, everyone. More than 200 years ago, the Scottish poet Robert Burns said that the best-laid plans of mice and men often go awry. I'm sure we all have first-hand experience with what Burns means. No matter how carefully we plan a project and no matter how carefully we try to anticipate problems, we're likely to encounter something unexpected and unwelcome that will throw our plan off course. Well, class, today we'll be looking at how plans can go right or wrong, and how we can make sense of this. Are you all familiar with Murphy's Law? Well, according to Murphy's Law, anything that can go wrong will go wrong. So we'll be looking at everyday examples of Murphy's Law. Things like why toast falls buttered side down, why it always seems like we choose slow lines at the supermarket, and why it is so difficult to win when we gamble. As you may know, we now have many different versions of Murphy's Law, and today I'd like to look at the science behind 3 of them. I'll try to show you that some things which have happened to you and which you may have thought were simply bad luck had nothing to do with luck at all. Now, what I'm saying is that there are some very good scientific reasons for many of the things that happen to us, and we're not victims of bad luck as often as we might think. When we consider some basic science and probability theory, we can more clearly understand why some bad things happen the way they do. All right, let's begin with a very commonplace situation. Let's say you've just gotten up. You're still sleepy, and you make your way to the breakfast table. In your half-awake state, you accidentally hit your piece of toast, which has butter on one side. The toast begins to fall to the floor. Now, what are the chances that you'll be lucky and the toast will land buttered side up? Well, the toast has only 2 sides, so most people think that the answer is 50-50, 50%, right? Do you think that there's a 50% chance that the toast will land with the buttered side up?
Well, this sounds like a trick question, but yeah, logically, 50% sounds about right.
Yes, 50% does seem right, but in this case, Murphy's Law of falling toast says, toast which falls from a table will land buttered side down. Actually, the probability of this happening is extremely high. It's close to 100%. Now, here's why. When something like a piece of toast falls from a table, its behavior is not random. The rate of spin is controlled by the laws of physics. This is the problem. The rate of spin, that is, how fast the toast spins, is too low for the toast to make a complete revolution. It's too slow to turn completely around and hit the floor buttered side up. The rate of spin is determined by the force of gravity. So, in a very real sense, the laws of physics, and specifically the rate of spin, make sure that our toast lands buttered side down almost all the time. So, the point is that simple probabilities, for example, the probability that toast has a 50-50 chance of landing buttered side up, can be greatly affected by other more fundamental factors, such as the laws of physics. So, in this case, we believe that we have bad luck because we don't understand that the natural laws of physics are in effect. The toast should land buttered side down. Okay? Let's look at the next point. Now, we come to one of my most frustrating situations in life, the supermarket line. In this case, Murphy's Law of supermarket lines says, the line next to you will move faster than yours. Now, everybody wants to get into the fastest line when they go to the supermarket, right? Okay, so let's say that you're at your local supermarket and there are 5 lines, but each of the 5 lines looks pretty much equal in length. Now, of course, you want to try to anticipate which one of the 5 lines will move the fastest. Well, this is where simple probability theory enters the picture. The chances that you have chosen the fastest of the 5 lines is 1 divided by the number of lines, which is 5 in this case. So, mathematically, the formula is 1 divided by n, where n is the total number of lines. So in this example, 1 divided by 5 gives us what?
1 divided by 5 is 1/5, or 20%.
Right, 20%. There's only a 20% chance that we have chosen the fastest of the 5 lines. Now, even if we reduce that to 3 lines, our line and the lines on each side of us, the chances we've chosen the fastest line are still only what?
33%. 1 out of 3.
Sure, 1 divided by 3 is 33%. So it's not just your imagination that one line near you almost always moves faster than yours. Simple probability theory shows that the odds are against you. If there are very many lines, the chances that you'll choose the fastest one is quite low. So, you see, it has little to do with luck, but we perceive that it does. All right, now let's look at a final situation that shows how we commonly misunderstand the laws of probability. We've come to Murphy's Law of Gambling that says simply, you will lose. Now, in the case of the supermarket lines that we've just talked about, probability theory applied very nicely. And actually, as we go through life, most things are fairly predictable because they follow the basic laws of probability. Weather is an example. Let's say that it's been raining for a week, and a friend says to you, I think it's going to be sunny tomorrow. Is that an unreasonable statement? Well, no. Clouds move, and they are of limited size. So if it's been raining for a week, it's likely that the rain and clouds will end soon. In other words, the next sunny day is more likely to occur after the 7th day of rain than after the 1st, because the storm front has what is called a life history. Now, this is important, so let me explain that term. Events with a life history have changing probabilities of certain events occurring over time. For instance, if you plant flower seeds, you can predict with reasonable accuracy when the plants will come up, when they will bloom, and how long they'll bloom. For instance, with some types of flowers, there's a 90% chance that they will come up 15 to 20 days after the seeds have been planted. In short, the growth of a flower follows a clear, predictable pattern, and we call this pattern a life history. But this is the trick with many gambling games. The casino owners want us to believe that dice also have a life history, and that we can therefore estimate the probability of events related to the dice. However, gambling devices like dice are different because they don't have life histories. Now, what do you think that means?
There aren't any reliable patterns? Just because I rolled a 7 last time doesn't tell me anything about the next roll.
Right. You can't look at the past rolls of the dice and predict what the next roll will be. Now, many people, especially gamblers, think that they can, but this is what's called the gambler's fallacy. The gambler's fallacy is expecting to roll a 7 with a pair of dice because a 7 hasn't come up recently. So, in other words, there's a widespread belief among gamblers that dice have a life history. In the real world, that's not a bad way to reason, but in a casino, it's the path to financial loss. Dice have no memory, no life history. Now, you can predict that if you roll one dice many, many times, the number 5 will come up about 16% of the time. That's 1 divided by 6. But that's not what we're concerned with here. We're concerned with the next roll of the dice. As a result, the element of arbitrariness or randomness makes prediction of the next roll impossible. Statisticians who work with probability theory call the roll of a pair of dice a single event probability. And many of these same statisticians believe that the probability of a single event can't even be computed mathematically. So, the same probability theory that works well with supermarket lines won't help you win $1 million in a dice game in Las Vegas. It could, in fact, lead to a catastrophe. So, to sum up, we have looked at 3 cases involving Murphy's Law and our perception of bad luck. The first case was the toast, right? Our toast lands buttered side down far more often than we would predict because the basic laws of physics have a strong effect on normal probabilities. The second case was the supermarket line, remember? Another line moves faster than ours because the laws of probability are behaving normally, even though we might perceive them as behaving unfairly. And the third case was the dice game. People lose at gambling games like dice because the laws of life history probability simply don't apply in those situations, even though gamblers think they do. So, as you can see, in some cases, Murphy's Law is not just some form of bad luck. There are some very real scientific explanations for these events. Okay, that's about it for today. For next class, I'd like you to take a look at Chapter 7 and be ready to talk about the discussion questions on page 255.